Hi friends, my name is Teacher Erica and welcome to a new segment with me called Science Time with Teacher Erica. That's me. So in this new segment, which is going to be a couple videos, I'm going to be showing you guys a few science experiments and we're going to talk about how they work. We're going to do them together and then we're going to come back together and we're going to talk about what we learned and if it was a fun experiment. And a big part of science, my friends, is figuring out if our experiment worked or if it didn't. And if it didn't, why didn't it work? How can we make it better? And in science, my friends, we always have a hypothesis. So a hypothesis, which is going to be right here, this is the word hypothesis. A hypothesis is something that you predict about an outcome. So for example, if you wake up in the morning and you look outside your window and you see a dark sky and you see a bunch of clouds and it's cold, your hypothesis for the day is going to be, I think it's gonna rain. That's what a hypothesis is. It's somewhat like a prediction, but it's in a specific format. And the specific way we say it is we use if ... then. So it's gonna look like this. It's gonna look like if and then. So for example, if we're still talking about rain, our hypothesis would be if it is dark, cloudy, and cold outside, then it's gonna rain. That's a hypothesis. And so for today's experiment, we are going to be learning about capillary action. Now, my friends, you might be wondering, Teacher Erica, what does that even mean? Well, I will tell you. Capillary action is a scientific term for a liquid, which is like this. It's like water, soda, juice. Anything that can fill the shape of a container it's in is a liquid. So it looks like this right here. This in this little beaker I have right here. This actually isn't a beaker, my friends. This is an Erlenmeyer flask. So this Erlenmeyer flask is filled with a liquid. When you drink water, you're drinking a liquid. And so a liquid is something that can take the shape of any container it is in. So basically, capillary action is the ability of a liquid to move from one place to another without the help of gravity or even against the help of gravity. Now, do my friends know what gravity is? You guys might. Yeah, it's a little complicated to explain, but basically, I want all my friends to get up right now and I want you guys to all jump. I'll jump with you. Okay, ready? 1, 2, 3, jump! So, Teacher Erica, what does that have to do with gravity? Well, if we didn't have gravity, you guys would jump up and you just keep going and going and going all the way into space because you wouldn't have gravity to hold you down to the ground. So gravity is this force that we can't really see, but it's what keeps us and everything around us on the ground. It keeps us all from floating up into space. And so because gravity keeps us from floating up into space, you can also say that it pulls us down towards the center of the earth. So friends, you're probably thinking, Teacher Erica, what does gravity have to do with capillary action? I'll tell you. So basically, like I said, capillary action is the ability of a liquid, like water, which I have in this cup, to go from one area to another. But it's gonna go to this other area without the help of gravity, or it can even go against gravity, which means that instead of going down, it's gonna go up. So I have another example of how gravity works and how this is not how our experiment's gonna go. So I have water in this cup is empty. So taking what we learned about gravity, can my friends tell me, make a hypothesis about what's gonna happen if I take this cup and try to pour it into this cup? What's your guys' hypothesis? That's a good hypothesis, my friends. I love it. So my hypothesis is that if I have water in this cup, then it is going to pour down into this cup because of gravity. So let's test it out. I'm going to pour it. So all my friends see how the water is going down. That's because of gravity. And that's an example of gravity pulling something down, similar to the jumping activity we did a few seconds ago. So like I said, that is not how our experiment is gonna go. What we are going to do instead is we're going to take some jars or some glasses that you can see through. We're going to color them different colors, and we're going to take paper towels and see through the paper towels how capillary action works. So we're going to see, first of all, we're going to see if it works. So my friends, I want you guys to think, I want you guys to make a prediction, make a hypothesis, and think, is this experiment going to work? All right, do my friends have their predictions? Yeah? Awesome. Okay, friends. So now we're going to head on over to my kitchen, and I'm going to tell you guys what you're going to need for this experiment. I'm going to show you guys a time-lapse video of how this experiment works, because this experiment does go a little bit slow. And then we're going to come back and we're going to talk about it, and we're going to talk about what we learned today. All right, friends, are you ready? Let's go. Hey friends, I am in my kitchen, and so I'm going to perform our science experiment here because in case I make a mess, it will be a lot easier to clean up. So what you're going to need for this science experiment is you're going to need 5 jars. You can use 3, you can use 7, as long as it's an odd number of jars. And they have to be clear so you can see all different colors that we're going to make today. So once you have your jars, you are also going to need water. You're going to fill up the first one, the third one, and the 5th one. If you had 7 jars, you would fill up the 1st, the 3rd, the 5th, and the 7th. But for this one, since we only have 5 jars, we're going to fill up the 1st, the 3rd, and the 5th jar with water. Then you are also going to need food coloring. You can use any color of your choice. I have blue, yellow, and red because you'll see. And you're also going to need a spoon so you can mix the food coloring into your jars. And last thing you're going to need is paper towels. So you're going to fold your paper towels so they look like this. And I'm going to show you right now how you're going to fold it. So you're going to take your paper towel and you're going to fold it in half like this. So it's going to look like that. And then once you have it like this, you're going to fold it down like that a bunch of times. I just did 3. If you're going to do 5 jars, you should use 3 paper towels because you're going to put these between these two, and these two. So you're going to need 3. You're actually going to need 4 paper towels, friends. Alright friends, so once you have all your materials that you need for this experiment, you are going to put your food coloring into the jars that have water in them. And you only need about 5 to 10 drops of each color. So I'm going to start with this yellow. I'm going to put it in this jar right here because this jar is already a little bit yellow. I didn't have a clear jar for this one, so that's why I'm going to put yellow in it. So I'm going to put yellow in this jar, and I'm going to put blue in this jar, and then I'm going to put red in the last jar. So I'm going to mix those in and I will be right back. Alright friends, so once you have your jars filled with your food coloring, now we're going to take our paper towels and we're going to fold them like this, and we're going to put them between 2 jars. We're going to put them in one jar that has water, and then the other end is going to go to the jar that doesn't have water. So like this. And you should see that the water is going to start going up the paper towel. It's going to start soaking the paper towel and get it really, really wet. And so you're going to do that for this one. And then you're going to do it for this one. And then you're going to do it for the last one, just like that. So what you'll start to notice is that the water is going to start going up through the paper towels, like you can see right here on the blue one. So you can see the water is already going all the way up. It's almost reached the middle right here. And once the water is soaked through all the paper towel, it's going to start filling up the glass. This experiment, my friends, might take a while because it's going to take a long time for the water to go all the way up to the paper towel and all the way down into the next jar. So while we're waiting for the water to move, I want my friends to predict what colors you guys think are going to end up in these 2 jars. So let's go over what colors I have already. I have yellow here and blue here, and then I have red here on the end. So if we mix yellow and blue, what color do my friends think is going to come out here? That's a good guess, my friends. What do I think is going to come out here? I think green's going to come out right here. I think so. And so if we go to the next one, if we have blue and red mixed, what color are we going to get in this jar? You guys think so? I think so too. I think we are going to get purple in this jar, because when we mix purple and red with our crayons or markers, we get purple. So I think when we mix it with water, we're also going to get purple. Alright friends, so like I said, this project is going to take quite a while, because it's going to take a long time for the water to go up and down into the empty glass. So what I'm going to do is I'm going to insert a clip that has been sped up, so that way you guys can see the water moving a lot faster. So I'm going to insert that right now.
Much later.
Alright friends, welcome back from the time lapse. I hope you guys enjoyed watching it and that you were able to see a little faster just exactly how capillary action worked. So let's review what that term even means once again. So capillary action is the ability of a liquid, in this case water, to move either against gravity or to move without gravity's help. Again, in this case, it was moving against gravity because it had to move up the paper towels and into the next jar. So my friends, looking at the glasses the way they are here, I'm going to put this behind these ones so you guys can just see the colors a little better. So yeah, now that I have this behind so you guys can see the colors a little better, what do my friends notice? Yep, I see it too. I see that we have a nice green color here, but we don't exactly have a very purpley color right here. It might be a light shade of purple, like a pastel purple, and pastel means a really light shade, but it doesn't look like it's exactly purple. So my friends, I want you guys to rate this experiment how it went. This thumbs up means it went really good. A thumbs in the middle means it went okay, it kind of worked but not really, and a thumbs down means it didn't work at all. Alright friends, 3, 2, 1. My thumb is not exactly up, but it's not exactly all the way to the side either. It's like this because the experiment was fun and it did work, but it didn't work super well just because of the purple. My thumb would be like this if the green looked a little weird too, but because the green looks really nice, my thumb's like this. It's a little diagonal, which means it's not straight, but it's not sideways. It's like this, slanted. So my friends, what are a couple of things that you guys think we could do differently if we were to do this experiment again that would make it work even better? And by work better, I mean would make this color look a little more purple. Yeah, those are some great suggestions, my friends, and it shows that you guys made a lot of observations during this experiment, which is a great quality for scientists to have. So I think that next time we should probably have bigger jars, because as my friends probably noticed, this big yellow jar caused the water to move a lot faster than these tinier jars did, right? Yeah, I noticed that too. So I think we should have bigger jars. We should have more water in the jars, which if we have a bigger jar, we're going to be able to have more water. So those two kind of go together. And the last thing that I think is that we should add more food coloring. So my friends, I mentioned in the beginning you guys could add 5 to 10 drops of food coloring, and I originally added only 5 drops of each color to each jar. So I added 5 yellow, 5 blue, and 5 red. But I don't know if you guys noticed, but I did pop in a little bit during the time lapse, and I did add more food coloring to the blue one and to the red one. So I ended up adding 2 more drops to the blue one and 2 more drops to the red one, giving me a total of 7 drops in the blue and 7 drops in the red. And Another thing you guys might have noticed is that I did add a little bit more water to these two. And I added more water to these two because they were going very slow and I was trying to rush the process. But also because they just looked like they needed more water compared to the yellow one. This one was not going to run out of water anytime soon. But this one, the water level was already going down and it just looked like it needed more water in order to go from this jar to both of these jars. So that's another thing, my friends, why we would need a bigger jar is because our middle jar right here is not only moving from one jar to another jar, it's moving from one jar to two jars. So you would probably even need double the water for this middle jar right here in order to get an even bigger color in this jar. Something else I want my friends to notice is that these jars, let's look at the level of the water. And the water level is basically the line right here. Can you guys see my finger behind the blue jar right here? The line where the water is at, that's the water level. So the water level in these two jars is almost the same. The green jar is a little lower than this one, but they're very close. Same thing with the yellow. It's a little taller than the green, but it's almost the same as the blue. Now, if we go to these two, they are not equal with any of the other cups. Again, that could have to do with the fact that these jars are not all the same size. They're not the same width, which means that some jars are skinnier and some jars are more wide. Example, this jar is more wider than this jar. So that could be another reason why the water levels did not come out exactly right. And that could be another reason why this jar did not come out exactly purple. Another reason why this jar may not have come out super purple is that whenever we mix colors, sometimes if we have too much of one color, we don't get the color we want. So have my friends ever tried to mix two colors like green or like yellow and blue, and you put too much blue, so you maybe got a little frustrated because you wanted to get green but you just came out with blue with maybe a little yellow? Yeah, it happens to me a lot. So that's probably what happened here. I had maybe too much red food coloring in this jar compared to the blue jar, so the red kind of overpowered the blue, leaving us with a... What would you call this color, friends? I don't even know what color this is. We'll call it red purple. So giving us this red purple color that isn't exactly purple, but isn't exactly red. So yeah, again, my friends, next time we would probably need to add a little bit more blue food coloring because it's going to two places instead of one. And with that, my friends, I hope you guys learned a lot. I hope you guys made a lot of scientific and important observations through today's experiment. And we are going to head back to my green screen room to close out this video right now. Welcome back, friends. How did all my friends like that activity? Would you guys give it a thumbs up or a thumbs down? Or even a thumbs like this? Like, it was okay, teacher, but it could be better. Yeah? I personally would give it, I'm gonna give it not a thumbs up, not a thumb sideways, but a thumbs like that. Because it worked and that was awesome, but it did take a little while. But sometimes science does take a little while. We're not always gonna be able to do experiments that are gonna work just like that. Sometimes they take a little while to see, but the end result is always pretty cool. So my friends, what is something that you guys noticed once the capillary action actually happened and filled up the glasses in between the glasses that had water in them? What did you guys see? Yeah, good observation, my friends. So yes, the water in between the glasses did get to a pretty decent level. And if you mix the two colors of the two glasses that the cup was between, it turned the color of those two colors. So for example, the red and the blue, the water in that one mixed to purple. And for the yellow and the blue, that water in between those two jars mixed to green. Alright, my friends, I hope you guys had fun today during today's science experiment. I hope you guys learned a lot. You guys learned some new scientific terms like capillary action, some new words. You learned about gravity. You learned about what a liquid is, what a hypothesis is. So, my friends, you guys are now certified scientists when it comes to capillary action. You can go around and you can tell your friends, you can tell someone in your house, you can tell a guardian, you can tell anybody about how capillary action works because you guys are now certified in that field of science. And my friends, I hope you guys enjoyed this video a lot. Next month, we're going to be doing another science experiment, so I hope you guys look forward to that. And I will see you next time, friends. Bye!